Hello students, we're talking about combining functions in this video. So essentially we're going to be given two functions like f of x and g of x, and then we're going to look at some notation that looks like this: g plus f of x, or g minus f of x, or g times f of x. And all that really means is this first one here, g of x plus f of x, or g of x minus f of x, or g of x times f of x. We're even going to see some division, g divided by f of x, and what that's going to mean is g of x divided by f of x, provided that f of x does not equal 0. And I put this slash one way or the other. There's a proper way, but let's go and look at some problems here. So here we have problems that suppose that the functions g and h are defined for all real numbers x as follows, where g of x is 2x minus 3 and h of x is equal to 4x. They want us to write these expressions, g plus h, g times h, and g minus h, and this one here is evaluated at 3. Alright, so the first one, like we said, g plus h evaluated x is just g of x plus h of x, and that's equal to 2x minus 3 plus 4x. If we do the 2x and the 4x, combining those terms, we have 6x minus 3. Then here we have g times h, so that's g of x times h of x. So substituting the actual values in there, we'll just go ahead and distribute this 4x. So 4x times 2x is 8x squared, and the 4x times that minus 3 is negative 12x. Great, so there's the first two. Now this third one, before we plug in the 3, we will first figure out what g minus h of x is. So just writing 2x minus 3 minus 4x. Combining like terms here, the 2x minus the 4x is a negative 2x, and then minus 3. And then evaluating that at 3 would give us negative 2 times 3, just plugging in a negative 3 there for the x. Plugging in a 3 for the x. And then negative 2 times 3 is negative 6 minus 3 gives us negative 9. Alright. Yeah, we can look down here, and that problem right there is pretty similar. This one is a little bit different. Here we have two functions, h and g. They want us to find h divided by g evaluated at 2. So once again, not too difficult. Now the last one we wrote the whole formula out and then plugged it in. Another way of doing that would be like this. You actually just kind of do both at the same time. I'm going to write the function, and every time I'm going to evaluate it all at the same time. So I'll write h here and substitute 2 every time I see the x. So that's going to be negative 1 plus 2 times negative 3 plus 2, all divided by negative 6 plus 2 times 2. As you can see, just plugging in 2 every time I see an x. If you go ahead and run the numbers there, you'll end up with 1/2. Now part B is really one of the reasons why we're doing this, is to handle these weird things like this, where it says find all values that are not in the domain of h over g. You're like, okay, what is that? And if there's more than one value, separate them by commas. Okay, so when do I get situations that are not in the domain? Well, that basically happens. One situation is whenever the denominator equals 0. So we do not want the denominator equals 0. We also want stuff that's inside the square roots to be greater than or equal to 0. Okay, so you could, when denominators not, just kind of depending on thinking about this might not be the best way of summarizing it, but things don't work out if the denominator is 0 or if you have a negative value inside there. We want positive values or 0. So looking at this particular problem, the numerator is negative 1 plus x times negative 3 plus x. The denominator is negative 6 plus 2x. So we're really concerned when that sucker right there equals 0. And so we say negative 6 plus 2x cannot equal 0. And we just perform our normal linear operations here that we would normally do with, like, if this was an equal sign. So whatever you do to one side, you do to the other, so on and so forth. Adding 6 to both sides, then dividing both sides by 2. We have a situation where x cannot equal 3. Another way of thinking about it is we could say that x equals 3 is the situation that is not allowed. So whichever way you want to put it, they're asking us to find the values that are not in the domain, and so the value 3 is not in the domain. All right, that's great. This one, very similar. See the -5, you can just plug in -5. Once again, finding the values that are not in the domain, I'll go ahead and write the function here. So this is f over g, where f is x plus 7, and g is x plus 6, x minus 6. So values where the values that are not in the domain is where this sucker right here, the denominator, equals 0. So that can't equal 0. When you have two things multiplied together, so that means that the x plus 6 cannot equal 0, and the x minus 6 cannot equal 0. So solving for x, we get x equals -6, subtracting 6 from both sides, and x cannot equal positive 6, adding 6 to both sides there. So when they say find the values that are not in the domain, we would answer 6 and -6. All right. This is a little bit different. This says suppose the functions f and g are defined as follows. So we have f of x is equal to this rational function, and we have g of x is equal to this rational function. And they say, all right, find f over g, then give its domain using an interval or union of intervals. So this is a little bit different, where it's asking what values are allowed. Okay, what are the allowed values? And then we'll simplify the answer. So what we're going to do is we're first going to find the domain limitations before we do any simplification, because doing the simplification can sometimes limit the values. How can I put it this way? If the actual function is f over g, there might be some limitations on just that, but then when we do the simplification, some of those numbers can cancel each other out and stuff like that. And we will not be able to see all of the limitations that do exist. So let's go ahead and actually do some math here. So f is x divided by x minus 9. G is x plus 1 over x minus 9. So first off, we can say that right there cannot equal 0. X minus 9 cannot equal 0, so therefore x cannot equal 9. That's out. Then this whole denominator, notice because we have a large fraction here, so this term right here, x plus 1 over x minus 9, cannot equal 0. So when does this fraction equal 0? This whole thing, this fraction in the denominator? Well, a fraction will equal 0 if the numerator equals 0. So as a result, we have the situation where we can say x plus 1 cannot equal 0. Therefore, x cannot equal -1. And then this right here, x minus 9 cannot equal 0. That's the same as we had the situation up there, 9. All right, so me personally, I like to draw a number line because it makes everything really nice and easy. So let's go ahead and draw a number line. And we've got 9, which is not allowed. We have -1, which is not allowed. And then I'll just go ahead and shade in all the places that are allowed. I am allowed to have x values. And then make my domain using an interval or union of intervals, to quote the problem here. So everything pretty much from -infinity up to -1, that's allowed. Remember, with negative and positive infinity, you're always going to put a parentheses here. And then I'm going to union that with the region from -1 to 9. Notice these are open circles, and once again, open circles have parentheses. And then I'm going to union that with the region from 9 to infinity, and that's a good answer. That's the domain using interval notation. However, I also need to take care of this part right here, which is find f over g, and they want us to simplify it. So I'm going to simplify this fraction right here and write it as the numerator, which is x over x minus 9. And then instead of going divided by the denominator, I'm going to say multiplied by the reciprocal, flip it, of the denominator. So I have x minus 9 over x plus 1. I put parentheses around all of these so you can see that they're all unique terms. And we have x minus 9, those two are multiplied. They're separate terms here in the numerator, separate terms in the denominator, so I can cancel those out. And I end up with a nice fraction here, x over x plus 1. So that's the answer right here for the f over g. And then right here we have the domain set there. All right. All right, this problem is actually kind of like the same here. So here we go down to another problem that's a little bit different. This says, suppose that the functions f and g are defined as follows. F of x equals 3x plus 1, and g of x equal to the square root of 5x minus 3. They want us to find f minus g, f times g, and then give the domains of those combination of functions using interval notation. No problemo. So f minus g is just going to be f of x minus g of x. So that's 3x plus 1 minus the square root of 5x minus 3. That's it. That's the answer to the first part. It's just this minus that. That's no need to simplify because that's pretty simplified as is. Let's go and look at the domain. So the domain, there's no fraction, there's no square roots, anything in this part right here, so this is fine. The only thing we're concerned about is we want to make sure that what we have here in the square root is greater than or equal to 0. If it was negative, then we would have imaginary numbers, and we're just going to assume, though they don't tell us, that they want the domain as limiting to all real solutions. So we'll say 5x minus 3 has to be greater than 0. It should be greater than or equal to. I think I'll fix that here in a second. Yep. So that means we'll add 3 both sides, then divide both by 5. And so we have x must be greater than or equal to 5/3. Or sorry, 3/5. So, and of course I mess up on this here, so we'll fix it here. No, it can't equal this. It's greater than or equal to 3/5. So let's erase that part right there. So greater than also means we can fill in the hole. And we've got everything bigger than that. So 3/5 with a bracket, comma, infinity. That is the domain of f minus g. And if we look at this part right down here, f times g of x, well, that's just going to be the first one, 3x plus 1, times square root 5x minus 3. That's it. That's good. No need to simplify it. If you notice here, that 5x minus 3 is the same thing as we had up there, so it's the same domain. So, same domain. Bracket 3/5, comma, infinity. Nice. We'll just glance at this one real quickly. It's a rational function, 1 over x squared plus 2, so, and square root of 2x minus 5. So, when we multiply those, we have the first term, f, times the second term, g. And if we wanted to, we could put that over top of this one. That'd be fine. When we look at the domain, we have both situations here. We have a fraction and we have a square root. So first off, with the fraction, we want to say that that denominator, x squared plus 2, cannot equal 0. If we solve this for x, we end up with x squared cannot equal negative 2. Well, we know that x squared is always going to be positive, so this will never happen, because if x is positive, a positive times a positive is a positive. If x is negative, a negative times a negative is a positive. So that's always going to be positive. We will never have a situation here where we end up with a negative number, or sorry, with a 0 in the denominator. So now we're just interested in this part right here. Once again, we'll write that this radicand right here, 2x minus 5, must be greater than or equal to 0. So that means that x has got to be greater than or equal to 5 over 2. So we plot that on the number line and filled in circle rather, and shade it to the right. So that's going to be bracket 5/2 up to infinity. There's those two parts. And then this part right here, f minus g of x, is just f minus g. We can see that. We can see that the domain is the same. And we're feeling pretty good. We've combined functions and through addition, subtraction, multiplication, division, and we have found the limitations on the domain and even written the domain using interval notation. So good work, and good luck doing this for your homework.